Hello everyone. So our today's lead code problem is key and rooms. So it is a lead code medium problem. It is a graph problem. The question state there are n rooms labeled from 0 to n minus 1. Means there are n node in the graph and node in the graph 0 to n minus 1 as the index. All the rooms are logged except the room 0 means room 0 is not logged. Your goal to visit all the rooms. However, you cannot enter a locked room without having the key. Next, we have given when you visit a room, you may find a set of distinct key in it. Means each room have the set of distinct key. Each key has a number on it denoting which rooms to unlock, and you can take all of them with you to unlock the other rooms. So, question state that we have given some rooms that index from 0 to n minus 1, 0 to n minus 1, and our room 0 is unlocked, and we can go to the other rooms like we can go 1, 2, and 3. If only we have the keys, means if we have the keys of 1, then we can go to the room number 1. At this room, if we have the keys of 2, then we can go to the room number 2. But if we do not have the keys of the room, then we cannot go to the rooms. So like we do not have the key for the 3, so we cannot go to the 3. Then we go to the next node and check that if we find the key of this node. If we find, then we go to the this node, otherwise we will leave this. So this is our question. So what is we have to return? We have given a room array. Room I is the set of keys that you can obtain if you visit the room I. Return true if you can visit all the rooms, or false otherwise. Means if we can visit all the nodes of the graph, then we will return true, otherwise we will return false. So like if we apply on the examples, like we have given 4 nodes, means we have given 4 rooms 0, 1, 2, and 3. It is indexed, like you can check here, it is index 0, it is index 1, it is index 2, it is index 3. So we have given this. So at index 0 we have the keys of index 1, so we can go to the index 1, means we can go to the room 1. At node 1 we have the keys for node 2. We have keys for node 2, we can go to the node 2. At index 2 we have keys for 3, and 3 does not have keys. So we can visit all the nodes, means all the nodes are connected. So we can visit this node 0, then we can go to the 1, we can visit this, then we go to the 2, we can visit this, then we go to the 3. So since all the nodes are visited, so we will return true in this case. In second example, we have also given 4 nodes, means we have given node 0, node 1, node 2, and node 3. This is index 0, index 1, index 2, index 3. So at index 0, where can we go? We can go to the node 1 and node 3. At from the room 1, we can go to the node 3. We have keys of node 0. We have keys of this node itself. At node 2, we have only this node keys. and at 3 we have the keys of 0. So here you can say, you can check that we started from node 0. When we have keys of room 1 and room 3, then we can visit this, means we can visit this. We can also visit this, but we cannot visit the node 2. So we will return false. So how we will solve this problem? This is a very simple problem. We will make a boolean boolean array visited. Initially we will set all the values false, and we will make a DFS call. We will make a DFS call. Like we will start from node 0, like we have given this graph 1, 2, and 3. We have given this graph. We will start from node 0. We will mark, means like we have 4 node. So we will create a 4 node. Initially all values are false. So we visit node 0. We visit node 0. We will make it true, and we will check that does it have any neighbor. So it has neighbor 1, means it has keys of 1. So then we make a DFS request for this. We go to this node and we will mark it visited, like 0, 1. 0, 1, 2, and 3. We marked it visited. So we mark 1 as visited. Then at node 1, does we have any keys? Does we have any keys? That room is not visited. So at node 1 means at node 1 we have only one neighbor 2. We will make a DFS request for the node 2. So we go to the node 2, then we will return true. Means we will mark node visited. Then we check that we have any unvisited node that is not visited. So yes, we have unvisited node 3. Then we go to make a DFS call and go to 3 and mark it true. Then 3 does not have any value, then we will return it. 2 does not have any value, then we will return. 1 does not have any neighbor unvisited, so we will return and call it. Then we will check that is there are any values, means there are any rows, that rooms that are not visited, means the boolean array will be false for there. So if any false value we get, then we will return it. Like this is the case. Like in this example, if uh, let me draw this again. 0, 1, 2, 3, 1, 3. At 1 we have 3, 0, and 1. At 1 we have only 2, 0. We at 3 we have 0. So we have given this node. So we start from node 0. We have given, strictly given, that room 0 is unlocked. Then we will start from this room only. We are at room 0. Does we have any neighbors, means we have any keys? Yes, we have keys of 1 and keys of 3. Then we are making a DFS request. Then we visit the, like if we 0, 1, 2, 3. So first we will mark it visited. Then does it have any unvisited neighbor? So yes, we have one unvisited, so we will go make a DFS request for one and mark it visited. Does one have any unvisited? Yes, one have unvisited 3, so we go to the 3 and mark it visited. Then 3 has any unvisited? 3 has label 0 only, but it is already visited. So we will not go to the 0. We will return from this. 1 does not have another that is unvisited. So we will return from this. And 0, all neighbor are digital. So we will return. Then we will traverse in this array and we will check that is there are any value that is false. So yes, we have no two value false. So we will return answer false. So this is our approach. Let's see the code. Uh, so this is our main function. Let me zoom. This is our main function. N equal to rooms size means how many nodes are in our graph. So then we create a boolean visited array of n size. Then make a DFS request for static room means from room 0 and we will pass the visited array. So this is our normal code, normal DFS call start. Then when we make a DFS request, first we mark it as visited, then we find its neighbor means room dot get current means we will find its neighbor and find the keys which is labeled as the node. Then if keys are not visited means the node are not visited, neighbor node are not visited, then make a request for the neighbor node. In this way we will make a request. After that we will that our main condition we will check that is there are any room that is unvisited means there are any node that is unvisited. So if there are, then we will return false, otherwise we will return true. So this is our solution. So beats 100% user, so pretty efficient solution. So what is its time complexity? What is the time complexity? So its time complexity is big O. Its time complexity is big O of how many vertices? Means vertices we are traveling and yes, only big O of B means we are traveling only vertices. So big O of B. Space complexity we are only creating a Boolean space means big O of V. How many vertices are there? So this is our space complexity and time complexity.